Okay, this is another Vector Basics video in which I'll be covering the vector or cross product. Now, with the cross product, a cross product will provide you with a resulting vector, which, if using 3 dimensions, will give you a vector that is perpendicular to your 2 original vectors. So, Sarrus's rule is useful for any time, or for anyone that does not have much experience when it comes to matrices and using matrices and determinants. So, assuming that you aren't particularly strong with matrices and using determinants, the vector product of V cross U in this case, using Sarrus's rule, can be written as such. If we have V cross U, now a word of warning, V cross U does not equal U cross V. These are 2 different products, and I'll show you why now. So if we remember that each component can be rewritten as I, J's and K's, Sarrus's rule states that if we extend out a box around our components and rewrite them a little bit further, we can use the following to find our cross product. The right hand diagonals multiplied together, the components multiplied together, and then each line added to the total, and then the left hand diagonals subtracted away, will give us the cross product that we're looking for. So to go through this example, we have I times 3 times 2 gives us 6i plus 5 times 2 is 10j plus 1 times 0, which is 0. Okay, now you don't always have to write out zeros, but for tracking purposes it's probably good practice. And we are subtracting the left hand diagonals, sorry for being messy, so we are minus 6k minus 0 times 5 minus 0 I and minus 2j. Now if we look at each specific component, we have 6i plus 8j minus 6k, which can also be written as 6, 8 and minus 6, which is our cross product, V cross U. This is Sarrus's rule. This is an easy way to avoid using matrices and determinants if you are not confident with them. It's also a good way to check whether or not your method of using matrices and determinants was correct. Okay. If you have any questions or comments, please feel free to leave them below, and I'll see you in the next video.